Today we start on important topics related to algebra. Okay, we also known about that algebra plays important role in mathematics. Okay, so we start from one important crucial theorem in algebra. We known about that this one is familiar theorem, the fundamental theorem of algebra. Okay, the fundamental theorem for of algebra. Okay, also discuss this crucial theorem today. So we write this statement of this fundamental theorem first. Okay, then we also discuss this statement and obviously going to prove of this statement. Okay, the fundamental theorem of algebra obviously plays important role in algebra and mathematics also, which gives that this gives this one. Suppose that, okay, that means some consideration part. Suppose that pz equal to what? Pz equal to anz to the power n, an minus 1 z to the power n minus 1 plus dot 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 a1z plus a0. Okay, is a polynomial is a polynomial is a polynomial in PC. Okay, is a polynomial in PC of degree greater than equal to n, of degree n greater than equal to 1. Okay, then what happened? Then pz, then some conclusion part or some resultant part, then pz has a 0. Okay, that means pz has a root. Okay, so we have to prove this important theorem. First, we also known about that this one is pz is what? Just n degree polynomial where coefficient are belongs to C, that means set of complex number. Okay, that means such a polynomial in complex plane. Okay, or that means coefficients are belongs to complex number. Obviously this polynomial be degree n greater than equal to 1. Then we also going to show that pz has a 0. Okay, now we're going to prove of this crucial important fundamental theorem of algebra. We write this proof now. Okay, now we start this proof. We want to show that what we want to show that there exists z0 belongs to C such that, okay, there exists z0 belongs to C such that pz0 equal to 0. Understand? That means pz has a 0 means there exists z0 belongs to C such that pz0 equal to 0. So we're going to then how we handle this one. We also write it now. Okay, that means let some consideration, let m be the greatest lower bound of m be the greatest lower bound. Okay, greatest lower bound of what? Of modulus of pz where z belongs to C. Okay, and then we're going to further proceed for Okay, for mod z equal to a is greater than 0, we have what? Okay, that means for mod z equal to a is greater than 0, we have what? We also write in above is that portion and going to further discussion of that. Okay, so we also write it now. We have what? We have mod of pz equal to mod of a0 plus a1z plus dot 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 a n minus 1 z to the power n minus 1 a n z to the power n. Okay, then this greater than equal to what? This greater than equal to a n mod of z to the power n. Okay, difference a n minus 1 modulus. Okay, mod of z to the power n minus 1 difference this one minus mod of a0. Okay, not a problem at all. This equal to what? This equal to a right written is written this one equal to s to the power n difference a mod of a n minus 1 s to the power n minus 1 dot 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 a 0. Are you understand? Not a problem at all. Then this one equal to what? Sn common. Okay, then what is, we write it here. This one is mod a n difference mod of a n minus 1. Okay, is to the power minus 1 difference dot 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 a 0 is to the power minus n. Okay, then this one equal to what? This one equal to, we write it in this way. What we get modulus of pz greater than equal to s to the power n. Here mod of a n difference mod of a n minus 1 s to the power minus 1 dot 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 minus mod of a0 s to the power minus n. Okay, next we write it here because the last expression approaches infinity. Okay, we write it here because the last expression, okay, last expression approaches infinity as is tends to or approaches infinity. Okay, as is approaches infinity. Are you understand or not? I think this one is too easy. That means if s is tends to infinity, then pz is tends to infinity, and this expression also tends to infinity. Okay, so not a problem at all. Now we must choose a closed text. What we choose? We may choose a closed text. Okay, we may choose a closed text. Okay, then what happened? Closed text d about closed text d. Okay, about the origin such that what, we erase that portion and going to further discussion of that. Okay, such that mod of pz greater than m plus 1. Okay, if z is not in d, if z is not in d. Okay, then what happened? We may choose a closed disk T about origin such that P mod of Pz greater than m plus 1, because we see about that, or we assume about that m be the greatest lower bound of modulus of Pz where z belongs to C. So we talk about that we may choose a closed disk T about the origin such that phi z greater than m plus 1. Obviously z is not in D. That means without this closed disk, okay, without this closed disk, that means other domains are having this property pz modulus of pz greater than m plus 1. Understand? I think not a problem at all. Then we're going to further discussion of that. It follows that it follows that it follows that what? It follows that m is the greatest lower bound of m is the greatest lower bound of m is the greatest lower bound of those mod of mod of pz, okay, z belongs to C, okay, this one, because t is a because t is closed and bounded, okay, because t is closed and bounded so what happened? So there exists a z0 belongs to D. So it is that lower portion. Then we're going to further discussion of that. So what happened if D is closed and bounded and Pz be continuous? Okay, and Pz be continuous. We know about that all polynomial functions are continuous. Okay, so what happened? There exists what? Z0 in D, Z0 in D such that what? Such that modulus of PZ0, okay, equal to M. Understand or not? That means if this domain set we we construct one closed and bounded domain containing this origin, obviously this T, that means if z is not belongs to the, then modulus of pz greater than m plus 1. Why? Because it's tending to infinity, pz tending to infinity. So this one happen if we construct some closed D is closed wall containing origin and pz becomes continuous. That means some point z0 in this D and obviously satisfies pz is the lower greatest lower bound value, okay. Oh, that means infimum value satisfied by this pz. So we write it here, modulus of pz satisfied this, then modulus of pz0 equal to m. So not a problem at all. We're going to further discussion of that. Then what happened? We want to show that now we want to show that what? We want to show that m equal to 0. Okay, understood or not? I think all are understood. So we argue by contradiction. That means we argue by contradiction. That means contradictory we prove. Okay. Then what happened? We erase, not erase. Now also space is left, so we do it. Then what happened? Assume that m not equal to 0. Okay. That means we have to prove that m equal to 0. But we're going to be proved by contradiction. So we assume that m not equal to 0. Then what happened? Let qz equal to p of z plus z0 divided by pz0. Okay. Then what happened? Then qz, okay, then qz is a polynomial of degree, is a polynomial of degree n. Okay, and q0 equal to 1. How q0 equal to 1? This one is too easy. If we put q0, then pz0 by pz0, different, that means the numerator and denominator same, and obviously this one equal to 1. Okay, so q0 equal to 1. Now we're going to further discussion of that, so it is our portion. Okay, now what is remaining? Okay, that means, and obviously, and qz, okay, qz modulus of qz greater than 1, greater than equal to 1 for all z belongs to c. Okay, assume that m not equal to 0, and then let qz equal to this, then qz is a polynomial, this one q0 equal to 1, and obviously this satisfies that modulus of qz greater than equal to 1 for all z belongs to c. So we may write, what? We may write qz equal to what? 1 plus bkzk dot 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 here bnzn. Okay, why we write this one 1? Because if we put 0, then this one is 1, q0 equal to 1 satisfies. Okay, and then obviously qz equal to this one. Okay, that means pz plus z0, and obviously qz is a polynomial of degree n, and that means q0 equal to 1. So we write in this way, where obviously we write here where bk is not equal to 0. Okay, where bk is not equal to 0. So we erase lower portion and going to further discussion of that. Okay, then what we write it here? We write it in this way, because of minus modulus of bk by bk, okay, has modulus 1, has modulus 1. Why modulus 1? Because we take this mod equal to mod of bk by mod of bk equal to numerator denominator same, that means modulus is 1. Understood or not? All are understood, I think. We may pick what? We may pick a real number theta. Okay, that means theta belongs to R, such that what? Such that e to the power I k theta equal to modulus of bk divided by bk. Okay, that means this one has modulus 1, so we write it e to the power I k theta. Okay, or we write it in this way, e to the power I k theta bk equal to difference of, okay, minus modulus of bk. Understood? Then what happened? We write it here, for any r greater than 0, for any r greater than 0, we have what? We have here q of r e theta equal to what? Q of r e theta equal to 1 plus bk, here r to the power k e to the power I k theta plus bk plus 1 r to the power k plus 1 e to the power I k plus 1 theta plus dot dot dot, okay, plus here bn r to the power n e to the power I n theta. Okay, then what happened? We write it here, choose r so small, choose r small enough. Okay, small enough so that what we write it here. Hello. We write it here. Okay. Not we also write it here again. Okay. We not write, that means one step is needed here, so we erase that portion and going to further discussion of that. Okay. Then this one equal to 1 difference modulus of pk r to the power k. Okay, and plus, okay, bk plus 1 here r to the power k plus 1, and in this way we write it here. That means this one equal to, okay, modulus of bn, modulus of b, sorry, we not put here, we just put this one, not put those. Okay, so we write it in this way: bk plus 1 rk plus 1 e to the power I k plus 1 theta dot 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 bn r to the power n e to the power I n theta. Okay, then choose r small enough that, small enough that, okay, choose r small enough that one difference modulus of bk r to the power k, okay, greater than 0. Then what happened? Then here q of r e to the power I theta modulus of this less than equal to 1 difference modulus of pk whole to the power rk plus modulus of pk plus 1 r to the power k plus 1 dot 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 here pn r to the power n. Okay, then what happened? Then obviously we write it now, this one equal to 1 difference r to the power k modulus of bk and difference bk plus 1 here r, okay, r to the power k is common, then this one is modular, that means difference here mod of pn, okay, r to the power, sorry, we write it here, not here, dot 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 difference mod of pn r to the power n difference k. Okay, so now choose r so small that, now choose r so small that what happened? So small that, okay, the expression within the brackets is positive. The expression within the bracket, okay, be positive. Within the bracket be positive. Then what happened? Then obviously this one, okay, we obtain what? We obtain, okay, we obtain that modulus of q r e to the power I theta is less than 1. Okay, but this is a contradiction. Why contradiction? Because we know about that modulus of qz greater than equal to 1. Okay, so there is some contradiction. Okay, so we talk about that, we are done. That means we also arrive our result in this way, that, okay, we arrive this way that here modulus of pz0 equal to 0, that means p of z0 equal to 0. Okay, we get 1 z0, then what happened? Then pz has a 0. Okay, we also get this one. Now we also considered one corollary related this fundamental theorem for algebra. Okay, we write this corollary now. Okay, we write this corollary related to this fundamental theorem of algebra. If pz equal to a n z to the power a n minus 1 z to the power n minus 1 dot dot dot, here a1 z plus a0, okay, is a polynomial of degree n greater than equal to 1 with complex coefficient. Okay, with complex coefficients. Then what happened? Then there exists a complex number. Okay, there exist complex numbers c1 c2 dot 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 cn. Okay, not distinct, not necessarily distinct. Okay, such that pz equal to an z difference c1 z difference c2 dot 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 z difference cn. Okay, that means what? This one pz equal to 0. Okay, this one implies what? Pz equal to 0, then z equal to, that means pz has n root. Okay, if pz equal to 0, this implies z equal to c1 c2 dot 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 cn. Okay, either c1 or c2 c10. Then what? Then pz has n roots. Okay, how this one we prove? We not prove it, just write, that means talk about that proof. If this nth root, the nth degree polynomial in complex coefficient have one root, then obviously we write it what? We use this theorem, then we write it in this way: pz equal to z difference c1 multiplied by a in this way bn minus 1 zn minus 1 dot 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 b0. Okay, understood? Then what happened? Then again we write it in this way: z difference c1, and here obviously that means some an is common, because an is common in this rule. Then this z difference c2, and what? Here again cn minus 2 zn minus 2 dot 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 c0. Okay, in this way we get this result. So this one is too easy, we not prove this one, just we, that means give some hints about that corollary. Okay, we also, that means you also find this proof of that. Okay, so today we also, that means if you have in, that means you want to get this type of videos, please subscribe my channel, and if you give like, please click on like options, and if you have any comment, suggestions, questions, please that means write it in comment box. So today I stop here, and if you get this type of videos, please subscribe my channel. I also, that means I also appreciate for that if you subscribe my channel, because I also, that means give this type of videos more, and I think about that, that means I give something for others. Okay, so please subscribe my channel and encourage myself. Okay, so today I stop here.